So in this video, I'm going to show you how we can create a drone map using completely free drone mapping software. I'll be flying a DJI Mavic Pro 1. I'll be using the free Pix4D capture app, and I'll be using a locally installed version of Open Drone Map to process the data. Okay, so we've arrived at the property we're going to map. It's a relatives property because they're quite strict on where you can and can't fly in South Africa. So what I'm going to do now is on my phone, I'm going to open up Pix4D, which is actually what controls the drone while we're mapping. And I'm going to just map out the borders of the property. And we're going to be doing a polygon mission in this case. It's my favorite type of mission for 2D imagery. The first thing we need to do is find out where we are on the GPS, so we hit the GPS button. Alright, let's switch to satellite so we can see what we can see in the area. So this is the area we want to map. The white dot over there is me, and we want to map basically around this property. So we're going to start the basic map above us, and now we just have to drag the points to the corners of the property. It's quite simple to see. We're going to go down the tree lines and to the road, and that looks like it should do it. Now, the higher you fly, the faster the missions go, because you've got less lines to fly. But the detail gets worse. So at the moment, at 90 meters, we should have about a 3 centimeter pixel size. We're going to fly it a lot lower today. There we go. 30 meters, we've got a 1 centimeter pixel size, but the flight does take longer. You can adjust the track. The drones like to fly long missions, long lines at least, rather than wide angles. There we go. That looks pretty good. That's because it stops to turn. So the longer the lines are, the quicker it'll fly. And that's about it. So we can save that until we're ready to get the drone going. We can exit. Okay, so this looks like a reasonably good place to fly. So let me get the drone out and get it unfolded. Lens protection off. This is a nice compact drone. It weighs just under 750 grams, and it does really good work. Okay, I just want to make sure the props are not hitting any grass. Front is good. Alright, that should be fine. Controller out. Phone plugged in. Okay, so we're going to go and load the project. So we're going to go back to the next screen, waiting for the mission to upload. And if you just focus on the drone, we're going to be taking off in 3 seconds. Another airspace check. And I think we're good. Taking off in 3, 2, 1. Right, so I'm going to flick to the camera view so we can see what it's seeing. Looks okay. Alright, do you want to look over here, please? So the drone at the moment is flying on autopilot. My job is just to make sure that if anything comes into the area that I stop it from flying, and to keep an eye on the screen to make sure everything looks good. Okay, I'll flick to the map. You can see the route it's flying and where it's taking pictures. Okay, so we're pretty much finished, as you can see on the map here. What the drone's going to do now is it's going to come back to the point it took off from, and it should be auto landing. So the only thing I'm going to do while it's landing is obviously keep an eye out for it. Alright, so that noise means the drone is coming back to land. It's climbing to my come home altitude, which in this case is set to 45 meters. And then it's going to come back to the point of takeoff, and it's going to do an automatic landing. I'm going to keep my finger on the sport button here, which acts as a cancel button, which will remove the autopilot, just in case anything's going wrong. I'll flick back to camera so you can see what the drone is seeing. My camera lady is getting a little bit nervous, but everything's looking perfect. It looks like it's landing on the exact same spot that it took off from. Okay, and that's pretty much it. The next step is to go and take the data back home and to go and do some processing. Okay, so let's process some drone data. First thing we need is our memory stick on the drone. Don't drop it, they're tiny. And a little adapter for the SD slot. Alright, so I'm going to add a new project because I don't have anything for South Africa yet. And we're going to go and upload the images. Alright, so I'm already in the folder I need. I remember the flight was at about 2:10. So let's go find it. There we go. The nice thing about drone images is there's always a big gap between mapping, so you know where to start and where to end. Let's look for the next gap. There we go. Alright, so that's where it ended, 2:14. We're going to open that. Let's give it a name. Okay, I'm going to leave all the other settings standard, and I'm going to tell it to upload. Okay, it's fairly big, 440 megabytes, 90 images, so we've got a little bit of time to wait. Okay, and we're done. Let's go and see how the data looks. Okay, this is the area we're interested in, which is good. So we've covered everything with a bit of a margin for error. Let's go zoom in a little bit and see what the data looks like. Yeah, pretty good. We can see the bricks in the paving. We can see the plants quite nicely. We can see my cameraman, 1, 2, 3 dogs, drone bag, me in the hat. I think it looks pretty good. Edges of the buildings look nice and crisp. The leaves in the trees look great. Over here, there's a vegetable garden. If we zoom in, yeah, very neat. We can see the shade net covering, preventing the birds from eating the plants. I think this looks great. Let's move down. This is where the gate is. Let's zoom in over there. And it loads up quite nicely. We can even see the power lines running across the property. So if we go back to see what Google Earth had it looking like, not very clear at all. And then you can put on the drone imagery, and it looks great. Now, as I said before, we've got a surface model and a terrain model. We can't do the plant health at the moment because we don't have a multispectral camera on the drone that I was flying. But if we look at the surface model, there we go. You can see the lower lying areas and you can see the higher areas. Now the surface model shows you everything that's on the surface of the ground. So there's a house, there's some trees, there's another building, another building. But if you go for the terrain model, what it does in this case is it tries to work out what is actual Earth and what is put on top of the Earth. So you'll see it's removed most of the buildings. You can still see the foundations were there, but you don't see the trees, and it's an empty-ish property. We have also got something called a textured model. But to show you the difference of the textured model, I'm actually going to flip to one of my favorite data sets. Okay, so this was an area in Madagascar. They had some dikes separating the waterway from a number of agricultural fields. And after a big storm, the dikes burst through and it flooded a large area. So we flew over it in a double grid flight, just to show you what a double grid would look like. The drone would do lines going horizontally all the way across. It would turn 90 degrees and it would do lines the other way. And all while it was doing this, the camera was aiming at about a 45-degree angle. You can choose the angle, but that's what we'd set. So because of that, we've actually got pictures of what the side of the buildings would look like, and that lets you see what it would look like in 3D. So a very nice quality 3D image there. If you wanted to, you could plug this into a 3D printer, and you could actually print it out. And look at the other side. There we go. You can see where the water tore away at the dike. There's something else you could do. If you wanted to know sort of how much soil it would take to repair this, I'm going to flip to 2D quickly. What we could do is we could calculate sort of what the volume of a slice of this ground is. So let's go and do a quick measurement. So let's say we want to measure from here across to the other side, just a little area. Square meters, but it was basically 500 cubic meters of earth. Now, if we want to work out what length that is, we can go and do another measurement. Let's go see. All right, so 4.5 meters is 500 cubic meters of earth. Now what we can do is work out how much of this area is missing. So if we were to replace this whole area from there to there, we're dealing with, let's call it 100 meters. And we know that the little area is 4.5. And we're going to go and grab a calculator. Times 500 cubic meters. Okay, interesting. So we're looking at about 11,000 cubic meters of earth that would be required to fill this up. So if you knew your truck could carry 50 cubic meters, you can go and work out how many trucks you need or how many loads you need to go and have this repaired. Now, if you're wondering why it's called a WFP Drone Imagery Processing Snowball, it's because this system is installed on an Amazon Snowball Edge. We've got 2 Snowball Edges sitting in HQ. The one is with Marco, who's using it for AI. And this one is a CPU-heavy snowball. So let me go and show you what it looks like. We've got 6 terabytes of SSD space. That's lots of SSD space. And we've got nearly 200 gigs of RAM, so we can handle really big data sets. The other thing you can't see here is that it's running 48 CPUs in the background.